Welcome to clickmyproject.com. Let me discuss the project about iris recognition using possibilistic fuzzy matching on local features. In this paper here we are providing a novel matching algorithm with invariant properties for iris recognition system based on the local feature points extracted by a bank of Haber filters. The proposed matching algorithm, which is based on the PFM method, is used to compare two sets of feature points by using the information compressing the local features and the position of each point. Moreover, a fuzzy curve deduction method has been proposed to extract the inner and outer boundaries of iris from a gray level image. Here we are providing a new methods in image to iris recognition. Then feature extraction will be fine for image by Haber feature extraction. Then image recognition algorithm will be applied by feature in test and train features. Finally, it will identify or recognize the iris image for input image. It's the block diagram of our project. First we will load the image datasets. Then next one pre-processing. It's the noise removal process is done. Removing noise process is done by median filter. Median filtering is to replace each pixel value in an image by the median of its neighborhood. The next one is iris segmentation. Iris segmentation is the effective iris segmentation method is proposed to refine the deducted inner and outer boundaries to smooth curves for future extraction. Haber feature extraction are adapted to deduct the local feature points from the segmented iris image in the coordinate system and to generate a rotation invariant descriptor for each deducted point. The original fuzzy class deduction method can only produce a smooth curve represented by the cluster centers to fit the foreground pixels in a binary image. In order to apply the FCT algorithm, the gray level image has to be converted to a binary image. The next one is Haber feature extraction. Haber feature extraction is used to extract the local feature points from a segmented iris image in the coordinate system and to estimate the dominant orientation of each deducted feature point. After that, for each feature point, a rotation invariant descriptor is generated by using its dominant orientation. The next one is recognition, possibilistic fuzzy matching. In this algorithm, maintained previously may suffer from a problem of outliers because of the constraint is unfortunately in boost transformation estimation. The solution of the outlier problem in clustering is to use the possibilistic model that releases the column sum constraint. In addition, the nonlinear organization model is adapted to provide more accurate feature before matching for possibilistic fuzzy matching algorithm. Now let's see about the execution part. I am having mm.main.main and select the file, right click, run file, iris recognition using PFM on local features. Then select load test image button. Then here we have to select the input image. The next noise removal. Noise removal is done. Removing noise process is done by median filter. Median filtering is to replace each pixel value in an image by the median of its neighborhood. Procedure of median filtering: sort the pixel values, find the median, replace the pixel value by the median. The next one is iris segment 1. Iris segmentation. Effective iris segmentation method is proposed to refine the deducted inner and outer boundaries to smooth curves. The original FCT method is used to automatically select a threshold for both inner and outer boundaries of its iris. Then next you are select iris segment 2. FCT method is modified to extract the smooth curve directly from the grayscale gradient images. The proposed iris segmentation consists of two sets. In first, the gradient image around the iris boundaries in the rotational direction from the pupil to the sclera is generated. The next one is pupil is darker than the iris and then iris is darker than the sclera. The next one is feature extraction. Haber filters are used to extract the local feature points from a segmented iris image in the Cartesian coordinate system and to estimate the dominant orientation of each deducted feature point. After that, for each feature point, a rotation invariant descriptor is generated by using a dominant orientation. The next, load training features. is the Haber filters are directional bandpass filters which have orientation and frequency selective properties and provide optimal joint resolution in both spatial and frequency domains. In our system, the model of Haber filters proposed in this adapted to detect the iris feature points and to generate a feature vector for each feature point. The next one is recognition. Test image is recognized, then recognized iris. The proposed PFM algorithm attempts to estimate the Bose parameters such as translation, rotation, and overall scaling to achieve the linear alignment for iris matching. First, novel matching method is proposed to compare two feature point sets by taking into consideration the information compressing the Haber features onto two positions of each point. Finally, a matching score for two different iris images can be computed. A nonlinear normalization model is adapted to provide more accurate feature before matching for PFM. Thank you.